Alright, you're back with Mr. Candor, and we're looking at finding the turning point. So, the turning point is also referred to as the maximum sometimes, or the minimum point. It lies along our line of symmetry. So if we could cut our parabola in half, right, somewhere around there, then we would find that that is where our turning point would be. It's right the spot that makes it a mirror reflection of itself. So this is where you can bring in kind of transformations a little bit to help you out. Lots of different maths can help us. So we call it a turning point because this is where the values turn and repeat. So looking at our table of values just down here, for example 1, notice that around this point, that would be our turning point, because on the right side, if we go one integer over in our x, so this over to this 2, we go up 1 to the y. If we go 1 to the left of that 1, we are at 1 again. So our 1, 0 is our turning point. Now, we want to do this graphically, though, and without a table of values, because you're not always going to be given a table of values. Sometimes you'll just be given a graph. So we can always look here and go, okay, well, where is it? It's right there. That is our point 1, 0. So graphically, they actually just want you to look and observe. If you're so lucky to be given a table of values, obviously check your work. So now, what type of point is this? Well, do we have a maximum value? That's what I always like to ask. These lines keep going, right? So we don't have a maximum, right? Do we have a minimum? Oh yeah, that it comes to a minimum. I left none on the list just because you can have it where you just don't see one. And so you might say that there is no turning point. But that's when you usually start talking about local mins, local max, and it's not very often. So here, we're looking for the turning point. So here, that's our lowest point right here. That is at -1 and -2. So we can write it as -1 and -2. And it's a minimum. Okay. So you can also see it from here. So it's good to check the work. Lastly, we're looking at this example. So here, we brought up this before. So our minimum is here, right? And because I had to draw this line, I don't actually trust myself that much, right? I don't actually trust. So I'm looking here, because this is where my values are. And so normally if we have two values next to each other when we're trying to find, say, a median, we would split the difference, right? So we'd look at these and split the difference. So halfway, right? So that is where it's 0.5. And this is where if you evaluate your function where x is 0.5, we'll find our y value. So even though it says graphically, this can help you double check your answer, or if you want to just be more precise. But I would still make sure you're showing it graphically by showing some lines on it and trying your best that way. So here, we're putting in and we're getting 0.25 after we square it, minus 0.5 plus 3, which is 2.75. So pretty close to actually what we have there. What type of point? Well, it's another minimum point. So what do we notice with all these minimum points, right? Because they all turned out to be minimums. Well, all the minimums look like u's. And all the maxes would look like n's. Also, these come from x squared. This only happens if you have negative x squared. So based on the equation, it can give you some ideas around it all.